Good afternoon. I'm in the grown-ups room. It's quite exciting. Who was in Sam's talk just recently? Have a quick show of hands, so quite a few overlap. I was quite worried when he started. I hadn't seen that talk before. And you'd think, both of us working for Thoughtworks, that we'd somehow synchronize and work out what each other were going to be talking about. We didn't, of course, because that would be far too easy. So I was a little bit worried that he was going to cover off everything I was going to cover off. Fortunately, that's not the case. So don't worry too much. Thanks for the introduction. This is my first trip on the YOW, well, my first year I've been on the YOW tour. It's pretty full on, pretty exciting, and I'm really pleased to be here. The last time I was in Brisbane was for the British Lions tour some years ago now, and that was a crowning achievement in my life. This is the second, the grown-ups room at YOW Brisbane. So, I mean, you know, modulo birth of children, wives, etc. Right? Or maybe not the British Lions, maybe that is. But anyway, I didn't say that. So I'm going to be talking about building systems that are never done. So what does that mean? Excuse me. What do I mean by never done? There's a number of different ways you could look at this, right? So the first definition, I guess you could use, is this definition. So building systems that are incomplete, somehow broken, somehow not having all the necessary or appropriate parts. I'm not going to be talking about that because that sounds like a bad idea to build systems that look like that. Instead, I'm going to be talking about systems, to coin a phrase of Chad Fowler's, that we can leave as a legacy, a positive legacy for our children, for our development colleagues who come after us. Who in the room likes working on a legacy system, or would like, if you were asked, you know, we've got this new project, it's going to be working on this legacy platform, who in the room would jump at the opportunity to do that? There's someone at the back, so that's one person, so they're quite fun. I mean, I like this idea of Chad's that legacy is, you know, we're the only place really where legacy is a negative thing, right? If I leave a legacy for my children, I want to leave a positive legacy. Bach, Mozart left a positive legacy for us. Right? This is the sense I'm thinking of when I think about never done, leaving systems that are positive legacies. There's an old paradox from Greek philosophy. Plutarch first stated it. He talks about the ship of Theseus. Now, the ship of Theseus was built for Theseus. It went off sailing. And the paradox is, at what point does the ship become a different ship? So if you imagine you set sail on this ship and you hit a storm, and you know the mast gets brought down, so you replace the mast, right? And then, you know, a bit later on, you hit some rocks, and you cave in the side, and you've got to replace some of the planks. You can tell I'm not that into ships. I don't really know what the right term. Hull, maybe. So you have to replace parts of the hull. All right. And the paradox is, at which point, if you replace every single component part of that ship, at what point does it become a different ship, or does it become a different ship? All right. And that's how I sort of think about building systems composed of microservices these days, right? We're building systems composed of smaller services, right, where we can change individual parts of them without affecting the behavior of the system as a whole. So the behavior that your customers, the clients of that service, of that software sees rather. So building systems that are never done. This is me. Composed entirely of eyes, according to Google. So I've been at Thoughtworks about 10 years now. I started off as a developer, software developer. Over time, I've done more and more, sort of been interested in more and more aspects of design, distributed system design, specifically using things like web integration. I still write code, probably allegedly 70% of the time, probably more like 50%. So I'm still a hands-on developer. About a year and a half ago, a bit longer, I was privileged to go for a sleepover at Martin Fowler's house. Now that's something that not many people can claim. I took my onesie, packed that, and off I went to Boston. Martin Fowler is the Thoughtworks chief scientist, and we spent some time, about a month actually, end to end, writing this paper on microservices. Incidentally, I am the first author of this. You can see it, right? Woo! And in this paper, we talk about the different characteristics that we were seeing on projects, both inside Thoughtworks, but also in the big organizations, the Netflixes, some of the big investment banks, front office development, the Twitters, and so on. We tried to describe the characteristics of the systems that they were building and the organizations in which they were building them that made microservices, if you like, the term microservices, or the microservice architectural style work for them. We weren't trying to define microservices, and this is an important point. We weren't trying to say, this is what microservices are, you have to do this. We were trying to explain the things that we were seeing and come up with a name for them. So before I go into the rest of the talk, I'm going to clear up this, because this is the main question I get in the training courses or on Twitter. That's all very well. Microservice, micro implies a size, so how big are they? And the best way I've come up with for describing this was a technique I've been using internally in Thoughtworks to help out our demand people, right, our sales folk. Because, of course, our demand people are very interested in microservices. They're very interested in how big they are, because they want to know if they can sell 10 and you get 2 free, or that kind of thing, right? So I was trying to work out how to describe this to our salespeople, and we said, okay, well, if you imagine a normal size service, all right, it's about this big. This is the size of a normal service, and a microservice is about this big. So that's the size of a microservice. And at this point, I'd like to thank you all very much for coming. Thank you very much. No, not really. So never done. Back to never done. What do I mean by this? So the ship of Theseus is an older sort of example of this paradox. My favorite description of this comes from Terry Pratchett. I only read books that have, well, I guess, spaceships and elves in, sometimes mathematicians, but usually spaceships and elves. Terry Pratchett writes books with elves in. This is one of his books, The Fifth Element. And in this book, he describes, he talks about, well, there's a character called the King of the Dwarves. And the King of the Dwarves talks about his family's axe. He says, to paraphrase, this is my family's axe. It's been in our family for 900 years. We've replaced the blade, of course, right? Because we've sharpened the blade, we've replaced the blade. We've replaced the handle. Sometimes we've added extra carvings into the handle. But is this not 900 years later my family's axe? So that's really what I'm thinking about when I'm thinking about microservice style of architecture and building systems that are never done. Neil Ford, who's a colleague of mine, he talks about microservice style as being possible these days because it's the first post-DevOps architectural style. Right, these days we've got programmable infrastructure, software-defined networking, we've got compute on demand, elastic compute, and all these things come together to make this style of architecture possible. Dan North, he hates the name microservices. He says, it's too much of a focus on micro, on size, and he thinks that these are a subset of replaceable component architectures. There are others. He's not here, annoyingly, because I was hoping to do some Dan North baiting. It's a bit like bear baiting, except more dangerous in a lot of ways. You might have noticed I'm wearing a T-shirt, which is it's an homage to the 1984 movie Karate Kid, Cobra Kai. That's the baddies in I'm the baddie in the Karate Kid. This is Dan's reaction actually when I first talked to him about this name. We were on a beach at another conference, and he immediately threw me to the ground. Slap. Yeah. He doesn't like this name, and I can understand why, because it is too much, there is a focus on size in the name. Unfortunately, when Martin Fowler names something, it tends to very much stay named. So unlucky Dan. Microservices is what we have. So the future's scary, right? What do I mean by that? Well, Adrian Cockcroft was talking, I presume, this morning about Werner Vogel's and the evolution of the microservice style from Amazon.com, where AWS came from. This is actually the 2004, or an extract from the 2004 memo that Jeff Bezos sent. It talks about, externalizable interfaces. All teams must communicate through services. No more database-to-database integration. And down the bottom, we've got this famous line: anyone who doesn't do this will be fired. Thank you. Have a nice day. Now, that doesn't work in the UK so much, labour laws being very different, very American thing to do, but it communicates the intent of what they were trying to do, or what they were trying to do at Amazon. And, Amazon, yada, yada, yeah, unicorns, etc., right? But if you progress a few years into the future, if you go forward in time a bit, time passes, and these days, most of the big organizations, a lot of big web-scale organizations are using this style of architecture, which is great, They're getting a lot of benefit from it, a lot of value. It enables them to go as fast as possible. Quotes, I'll come back to that. And the interesting thing about these companies is they're doing things a bit differently compared to your usual big corporate. I spend a lot of time as a consultant, big retail banks, big insurers, and so on, right? And some of the things that they're doing you can only dream of in these big organizations, big enterprises. So this idea of deployment on demand, small services deploying on demand, right? And this is not the release train idea where every month we can push everything out, or every fortnight we can push everything out, or every week we can push everything out. This is, I can push a button as soon as my feature is done, and it can get out into production, and it can make us money as quickly as possible. So this idea of minimizing the cost of delay. This is very related to Don Reinertsen's keynote at lunchtime as well, or after lunch. They can also do things differently with respect to scaling teams. Right? So you can scale more people around something with a bigger surface area. Yes, of course, you can't ever address the mythical man month the findings that still holds. You can't just infinitely scale people around these things, but you can scale more people around these things, and they can operate at web scale if they need to. And this is an interesting. This brings me to an interesting sort of train of thought recently, which is around this idea of something called the innovation gap. If you're one of these big web-scale companies able to do this sort of stuff, right, able to take advantage of this style of architecture, of things like public cloud, be cloud native, then you get a bunch of these nice properties. And when I've been at these big companies, they're terrified, genuinely terrified about the implications of not being able to do some of this stuff. So I think Matt Heath is going to be talking about, revolution in modern retail banking at this conference. And this is an example of that. You go to the retail banks, they're terrified that these startups are going to take all their customers, even though they've been established for a very long time. They have this fear of the unicorns and how fast they can go, right? Whereas they're unable to do this because they're stuck in this kind of using the same old approaches. Don't press that one, press a different one. Press this one. And this brings up to this, this idea that they're sitting there in the corporate boardrooms, and they are genuinely terrified. They're seeing these startups. They're seeing these startups starting to take their customers from them. They're home alone, and they hear these creepy noises. Because what's interesting is that microservices should allow us to go as fast as possible. This is the promise. This is the aim, of this style. We should be able to take advantage of being able to scale teams, being able to scale our software. We should be able to take advantage of the fact that we can replace bits really, really quickly, independently of other bits, and we should be resilient in the face of imperfect networks. As fast as possible, that's a direct quote from Adrian Cockcroft. That's why Netflix adopted fine-grained service-oriented architectures, in his opinion, to allow them to go as fast as possible. But the thing is, it's not as simple as that. It's not as simple as just saying, we'll adopt microservices, right? Woo, microservices, as Sam said, Docker, 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 microservices, microservices. Microservices, go, go, go. It's not as simple as that. This is something that came from the recent edition of the Thoughtworks Technology Radar. So we talk about this idea of high-performance envy or web-scale envy, and this being on hold, because it's a particular affliction that big organizations have, or even smaller organizations. They all want to be like Google. They all want to be like Netflix. They all want to be like Twitter, like eBay. And so they jump onto these new styles that these big companies are using, and often run into significant problems because they forget, Netflix didn't just suddenly arrive at the point where they're scaling 1,000 services across tens of thousands of nodes. Google didn't just implement, a platform which requires tens or hundreds of thousands of pieces of infrastructure to operate. They grew to that gradually. And what's happening with these big companies now, jumping whole scale onto the microservices style, is they're starting to hit problems. There's impedance mismatch between the way they do things at the moment and the things that are required to build software using microservices effectively. So here's an example of what I mean here, right? A note on the law of unintended consequences. So if we consider a single website, we're just going to think here about how we're going to deploy this website into production, right? How we're going to integrate this website with its dependencies. So it's a sort of a thought experiment. We'll call this website A. This is how we might go about pushing this through into production. Tappity-tap, I'll write some code. We'll push through a build pipeline. If you haven't seen a build pipeline before, hello, it's 2015. This is how we build software now, right? So I write some software, I commit it into my version control system, it's compiled and unit tested somewhere on some build server, and it's pushed through acceptance testing, some form of integration testing into production, right? And ideally, we'd like to do this on demand, automatically. So we push through into production. So here's my question here. How many environments do you need in order to do this? The simplest possible case. Well, it's a single application. It doesn't need to be integrated at all, right? We don't need things like integration environments. We might need some kind of test environment and presumably some kind of production environment. So, a single environment, essentially. But what happens when we start layering on more services? Woo, microservices. Yay, we'll just have loads of them. So we'll start to add microservices. We'll add one, right? We'll call this B, or maybe we'll call it customers in this case. You'll have a web app and customers, and web app will depend on customers. It will use some data potentially from the customer service. So how many do we need in this example? Because what we want to do traditionally is work out, verify, when we make a change to, say, the web application, that it's going to work with all versions of the customer application, the customer service. That's pretty much what integration testing is for, certainly in big organizations. So, what does this imply? So in this example, we've got version 1 of the web app in production, version 1 of the customer service in production. All right, I'm going to make a change to the web app, git push origin master. This is the only code pretty much I've got in this. So coding architect. Git push origin master, and I'm going to bump the version to v2 of the web application, right? And that's going to be pushed through into our test environment. It can be compiled, it's going to be unit tested, and then it's going to be pushed through into our integration environment. At that point, we're going to run some integration tests. We'll have some big integration test suite that we're going to execute against this environment, against this application, and it's going to be deployed into production. Awesome. But the question is, what should you test that version against? What should you test version 2 of the web application against in your integration environment? You've got there's a pretty obvious answer. We want to make sure it executes, it performs correctly against, when tested against the production version of the customer service. So what we'll do is we'll test it against v1 of the customer service, okay? That's fine. But what happens if we start to make simultaneous changes? What happens if these services or these applications are owned by separate teams? What happens then? So maybe we make some simultaneous changes, and we'll start pushing these things through our build pipeline at once. And at some point, they need to fan in to be integration tested against one another. Right, so they'll do some WYSI integration tests at this point. Now, all of a sudden, we're hitting some kind of race condition where changes of or new versions of one application can overwrite versions of that application that we're integration testing against, and we end up with this kind of horrendous locking problem, right? Where we have to sort of start to introduce hats for people. Okay, well, I'll commit, you hold off, Right? You stay there, but I'll commit the code, and it'll go through, and then we'll integration test, and then now you can commit. Right? Right. So we start to get this introduction of locking. I didn't know this, but apparently I searched for an animated, I basically said, like, search for lock in Google image search. Turns out that locking is a subset of body popping. I didn't know that. So if you've learnt nothing today, you've learnt that, at the very least, right? But you start introducing locks into the system. And the fundamental thing about this is we're starting to hold up each other's teams, right? We're starting to introduce arbitrary delays between teams. We need to synchronize the work that we have to do between teams. So we're starting to introduce delays. And why is that important? Well, there's this idea of the cost of delay, essentially, right? Every time you introduce queues into your development process, you increase the cost of delay, where the cost of delay is the amount of money, essentially, that you could have made if that feature was in production, but you haven't made it because it's sitting in a queue somewhere. So every time we start to introduce these queues, we start to introduce batches into how we deliver software, we introduce delay, and we effectively have a direct economic impact on our top line. So, okay, maybe instead of having some kind of hat we wear and we'll lock between teams and so on, instead of that, what we'll do is we'll say, right, we'll create an integration environment per combination that we could test against. So we'll say, okay, right, I'll test my new version of the web app against both the production version of the customer service and a snapshot version of the customer service. Right? So that's fine, because we've got maybe Amazon, so we can introduce some elastic capacity, so we can start new integration environments up. That's brilliant. So maybe we'll have like 4 or 5 or however many integration environments. And that's fine, right up until the point, right, where you get the bill. Right? So suddenly you've gone from 2 services, we're going to have 4 potentially integration environments if we're doing the product. What happens if you start to introduce more services, right? Maybe 4's fine. What happens when you get to the point where you have 600 services? How do you verify that these things in an integration environment work correctly with one another? Integration environments. Hold that thought. I'll let you read that in a sec. Because I was thinking, at this point, right, and this is, I've seen this, I've had these conversations with tons and tons of people in our client side. If just this tiny little new thing, right, introducing more, like one new service, can massively blow out the complexity, the difficulty of something we take absolutely for granted, which is that we can integrate our software easily, right, by pushing them into an integration environment, running integration tests. I was starting to think, my God, what have I done with this microservices idea, right? Have I suddenly just caused, or me and Martin and the other people who are sort of talking about this, are we suddenly introducing massive additional complexity where people are just going to run off, say, microservices, haha, we'll shoot our problem with our microservices gun and blow their own head off because the additional complexity we're starting to introduce. I was starting to get a bit worried, so I started thinking about other things that we take for granted as developers, as a developer myself. And I was thinking, well, if things like integration testing are fundamental of how we work is difficult, what about other things, right? Integration testing's hard, or certainly maybe independent deployment becomes hard because of that. Maybe we have to start deploying things in lockstep, right? So we end up with distributed monoliths. Brilliant, the worst of all possible worlds. Like Scrumafall, right? It's like the worst of all possible worlds. It's like waterfall, but all the time. My God. Right? How are we going to do service versioning and evolution and so on? So if these things are hard, what about the other things? Now, there's a bunch of sacred cows that I'm going to talk to. Maybe World of Warcraft is specific to me, so I'll leave that one out. But these are a set of patterns, practices, principles that we take for granted, essentially, when we're building software. What about these? So the first question is, who's come across YAGNI in the room? You've got most people. So YAGNI, you aren't going to need it. So what are the implications for YAGNI if we're building systems composed of microservices? So there's a great article Martin Fowler put together on the economic cost of you aren't going to need it, rationalizing what that economic cost is. And he uses this diagram to explain it, right? So this diagram says, you know, the economic cost of building something before you actually need this can be quantified in a number of ways. The first thing is you might build the wrong feature completely, right? This is the kind of, we'll build this platform out, and you build it, they will come. We'll build a platform or a framework. So we'll build the wrong feature, and that leads to, you know, that implies there's a cost of building it, and there's also the cost of carrying that over a period of time. We have to carry that as inventory, and it implies there's a cost of delay. If you build the right feature, but it's built wrong, you have this cost of repairing it, and you also have this cost of carry plus cost of delay. And if you build, if you build the right feature and it's built right, you minimize the effect of YAGNI, right? Because you just have this cost of carry and cost of delay. You at least don't have to carry the cost of repair. So I was thinking how that relates to microservices, how that relates to how we build systems composed of smaller systems. And in that example, I'm thinking, well, actually, it does kind of apply. Because you know, none of the folk who are talking about microservices are suggesting we design all of our microservices up front, right? We'll design a microservices framework or platform, and then we'll go off and build it. Everyone is talking about building microservices around you know, either product lines of business, building microservices around you know, bounded contexts, and building them out as you need them. So in this case, I think kind of YAGNI holds, right? You aren't going to need it. Build out services as you need them, because that leads to minimizing your holding cost of those microservices and batch size. The next one, I like this one, because it often varies significantly the proportion of people who put their hands up. So who's come across GRASP? Yeah. Everyone's come across YAGNI, no one's come across the GRASP patterns. So this is from, I mean, these are probably decades old these days, from a guy called Craig Larman. These are some of the first patterns around, right? So this is the general responsibility assignment software patterns. And from the GRASP patterns comes two, well, linked, but really powerful concepts that we use all the time, we talk about all the time as software engineers. There's information expert is in there, there's a couple of others, but two that are in there, right, are related to, you know, things like, well, how we ensure that our software remains robust in the face of change to other bits of software. And this is high cohesion and low coupling, right? We want to build systems that favor high cohesion and low coupling. So low coupling meaning that, you know, they want to be resilient in the face of changes to other parts of the software, and, you know, high cohesion related to things like dry and SRP, which I'll come on to in a sec. And the interesting thing with the microservices style is there's been this massive sort of resurgence, you could say, in event-driven architectures, right? Messaging as well, or the equivalent, has become really, really popular. You know, Eric Evans at the moment is talking about, you know, domain events. So when any state changes in one service, you generate domain events as a fire hose, say, and other systems can observe those. CQRS is a really popular design pattern in the .NET world. So actually, it's almost like with microservice style, we're optimizing for high cohesion and low coupling. Right? Incidentally, this is how messaging works. So we're optimizing for this with the microservices style. So the next thing is this idea of dry, don't repeat yourself. Everyone, most people, dry, don't repeat yourself. Another sacred cow. You know, I will admit that I was a little nervous giving this talk the first time because Prague Dave Thomas was actually in the room. So this is a direct quote from the pragmatic programmers. Every piece of knowledge must have a single, unambiguous, authoritative representation within the system. So dry, don't repeat yourself. What does that mean with respect to building out systems composed of much smaller systems? Does this still hold? So there were two things I took from this. The first thing I was thinking about, the first thing is this idea of a system. They're not talking about a single application potentially. Potentially you could be thinking about groups of applications. And the other thing is every piece of knowledge in that system should have a single authoritative source of truth. And that's perfectly true for microservice style architectures. Right? As you decompose your system into smaller sets of services around your bounded contexts, you still have systems composed of dry services. They're still dry. Now there might be, there's some stuff online about how dry versus damp, right? So you should have individual services should be dry, but the system as a whole could be damp. And I think that relates to duplication in some ways. We can duplicate code across services, right? And that's fine, right? I'm a big fan of duplication of code. Copy and paste is a perfectly valid programming technique in my book, right? Is that okay with everyone? Like, I normally get more of a reaction at that point. Blimey, okay. So like, woo, go Brisbane. So cut and paste is a perfectly valid technique because essentially, if you are building out services, different teams tend to be building out the services, and in general, the cost of extracting shared dependencies and sharing them across different teams, again, it starts to introduce cost of delay, it starts to tie change cycles together. But that's not what Dry was talking about. Dry was talking about a single a piece of knowledge having a single authoritative source, a microservice. You could build microservice style architecture using the Dry principle. So Dry holds definitely across services, but across services as well, we don't want to allow this idea of extracting dependencies, duplicated code being evil to tie change cycles together. So the next one, back to Dan North baiting, yay, test-driven development. What does that mean when we're building really small services? And size varies. I was laughing about it's like a service, but it's this big. Size varies across organizations. I've been building this style of architecture for a number of applications that are implemented using this style for a number of years. And I've had services ranging from 100 lines of code up to a few thousand lines of code. I think Gilt have got some stats online, or certainly they were published in a talk, where they were sort of, the mean across their services are about 2,000. Then if you talk to Chad Fowler, he says actually what you need is, you need to be able to rewrite it in a day. Use any language, but you have to rewrite it in a day. Right? That implies a really small amount of code. Similarly, Fred George, hundreds, but no more than that. But if we are building systems composed of services that are that big, what does that mean for test driving our code? Right? If we can just throw this thing away and replace it, rebuild it really fast, do we need to bother with tests? That's the question I ask myself. And I've been very lucky in my career, and it is luck, I have to admit. Right? I've been very lucky. I joined Thoughtworks London 10 years ago, almost to the day. And at the time in Thoughtworks London, there were some people who went on to really, I wouldn't say change the industry, but certainly influence it in a very positive way. So two of those, for example, are Steve Freeman and Nat Price, who wrote Goose. This has been described by Mike Feathers as the London School of Test-Driven Development. So I was very lucky, sort of growing up, if you like, in this environment. Dan North was there as well. Jez Humble and Dave Farley of Continuous Delivery fame also there. So a bunch of intellectual. I was standing on the shoulders of those giants, if you like, in the same way that we are in this room sometimes. So the London School of Test-Driven Development. Should we bother, even if we're using this London school, should we bother with test driving our code if we're going to throw it away? And I had this. I get a bit not angry. I think angry is the wrong word, but my observation is lots of people are saying no, we shouldn't bother. We can just write these little things and that'll be fine. But a lot of the people who are expressing these opinions, they tend to be up on the expert end of the Dreyfus model. So the Dreyfus model is a description of how we pick up skills as individuals. And it applies for everything, including explaining the Dreyfus model. But you start off with novice, you go up to advanced beginner, competency, proficiency, and expertise. This is the 10,000 hours idea from pragmatic thinking and learning, if we've read that. It takes 10,000 hours to become an expert. At the bottom, we're rules focused. We move to intuition focus. At the bottom, we can't distinguish between what's important at the top. We can immediately see it, etc. I don't know how long I've been. I suppose I started test driving code about 15 years ago, probably something like that. I wouldn't say necessarily I'm an expert, but certainly the code I write now, if I don't write tests, looks like the code I write if I write tests first, if that makes sense. So, I tend to have small methods. I have small objects. They tend to be composable. I use, constructor-based dependency injection, these kinds of things. The code I write, even without tests, tends to look like it. I don't think that would have been the case if I hadn't spent 15 years writing code tests first. Right. So that's one thought I had. Which brings me to this next thing, which is that all rules are contextual. Right? This is the idea that, should we always write tests? Should we never write tests? This doesn't really make sense. This doesn't really make sense from an economic point of view. You have to spend money investing in writing tests. Yes. So, if you've got lots of small things, maybe you don't want to spend money in writing tests for all of them, but you certainly do for the things that are really important, really risky, I would argue. All rules are contextual. So I came up with this flow chart with the help of a friend, Alan Kelly, to describe, well, I don't know, let's see if it helps, right? So the question is, should I test drive my microservices? So we'll start off, and the first question we ask ourselves is, am I Kent Beck? Right. Now, Kent Beck, turns out he's quite good at test driving code, quite good at TDD. So he gets this idea that, that this is contextual, rules are contextual. He gets to make a decision about when to use test-driven development. So the next question, if I'm not Kent Beck, am I Dan North? And if I am Dan North, I'm not. But if I am Dan North, again, I've spent all this time, I've invested all this time. Right? I understand where I should be writing tests, where I should invest the effort. Otherwise, my suggestion is just use test-driven development. Right? And it's for a very simple reason. I mentioned the, and this is not about the testing side. I mentioned that I tend to write code now where the methods are small, the objects are small. I use constructor-based dependency injection and so on. The simple thing with tests is, if you write code that way, a lot of the other things I'm talking about become a lot easier. So if you're an expert, and you can make your own mind up, but otherwise maybe write some tests. So the next thing is SRP. SRP, single reason to change. Code should have a single reason to change. There's a restatement of this. Adrian Cockcroft talks about this. Dan talks about this. There was a tweet, achievement unlocked. Adrian Cockcroft mentioned the size of my head in a keynote, because the restatement of this is, a microservice should fit in my head. That's how big a microservice should be. And it's related to this idea from a project I was on, that a class should fit in my head. So this is my former colleague, Alistair Jones, demonstrating this. So this is the Neo4j code base. He's at Neo these days, and he's measuring a class in the Neo code base to see whether it's too big or not. Turns out this one is fine. This should be normal, 12-point, not 4-point font, obviously. Right, if you hold your head up to the screen, an object should be no bigger than my head. But it's turtles all the way down, and this is kind of the theme of this. I'm starting to see this coming through with these sort of patterns and the practices, the sort of sacred cows. Actually, these things start to seem to hold at these different levels of abstraction. Because when we were talking about the size of my head, we didn't really mean this. We had a serious point, which was that I should be able to understand an object, actually a method and an object, in its entirety. Right, same for a function, I should be able to grok it. And as we scale out to a bounded context, I should be able to grok the whole thing. As we scale up to a microservice, say, I should be able to understand the whole thing. It should all fit inside my head. So a service should be no bigger than my head. The next thing is keep it simple, stupid. So I like this quote from Dijkstra: "Simplicity is a great virtue, but it requires hard work to achieve it, and education to appreciate it. And to make matters worse, complexity sells better." And you need to look no further than WebSphere for this, right? Sorry. I mean application servers, right? Application servers in general increase the complexity of how we go about deploying code. They give us a bunch of stuff that it turns out we don't necessarily need these days. Increases complexity. So in order to answer the question in general, is this simple enough? Is the solution I'm considering for a design problem simple enough? I use this heuristic, which is, what would Joe do? What would Joe Warnes do? Now, he's another guy I worked with at Thoughtworks some years ago. He's got this amazing talent for making complex things simple. It's just incredible. An example of that is, so he was faced with the problem of, there aren't that many, small lightweight servers that do WebSockets a few years ago now. What am I going to do? Maybe I could use one of the big ones, or I could write one, right? Why don't I just write a HTTP server? It's a couple hundred lines of code, right? Now that seems counterintuitive, but actually it's making a complex thing quite simple, right? Keep it simple, stupid. So the next thing is this example. And this is an example from a project I was on where we were faced with, we had this big backlog for the platform team. We're going to, there's a big microservice architecture. So, the platform team were waiting to install, Dynatrace or whatever it was that was the big monitoring solution. We were going to get a production hardened console cluster running, which is going to do health check-in and all this kind of stuff, which is great. But up until then, we had really no idea what was running in production unless we went to the Amazon console, which sucked. So we just put this together in a couple of days. It's not, perfect, but this is, a couple of days worth of cron, Python, GOTO, PyDot, and GraphViz, and we had an idea. It's keeping it really simple, solving the problems in a simple way. So do the simplest thing possible. So then I was, looping back to this thing with integration environments. Continuous delivery seems like a sacred cow. Continuous integration, continuous deployment into production. Maybe there's something else we can use here to address this issue with integration environments, I was thinking. After all, this is a great quote from Peter Drucker, there's nothing so useless as doing something that should not be done at all. And I've always had this inkling in the back of my head that this integration stuff was sort of risk management theater. Generally, if you're writing unit tests, if you're writing, if you've got, acceptance tests where we're using mocks and so on, then, by the time you get to integration, we shouldn't be catching that many problems. So maybe the best thing to do is get rid of integration testing. Let's just not do it, all right, instead. Let's just test in production, all right? Get rid of it. But that relies on a few things. And I'm serious when I say this. This is where people's faces drain of color. But I'm serious when I say this. This relies on things like good monitoring. If you're going to push your code all the way straight through into production, you have to have really good monitoring in place. You need to know really quickly when things are going to break. You need to be able to fix stuff really fast if it does break. All right. But then you get to do this thing, QAing in production. There are some other things we can layer on top, other techniques. This is a simple technique called semantic monitoring. This is like running what used to be your user journey or acceptance tests against your production environment. I say just that. Of course, if you unpack that, there's a whole bunch of stuff underneath about having the ability to support synthetic transactions, the ability to redirect state-changing operations so you don't change the real state in your database and so on. But you can use this as part of your monitoring setup. You can also implement something called consumer-driven contracts. There's a great tool written in Melbourne called Pact, which implements this. And simply what you do, you write an executable specification, and you pass it to the service teams that you depend on, and they execute it as part of their build. So you're starting to add feedback loops into your build. So consumer-driven contracts. But that means if we start layering this stuff in, we can get rid of our integration environments. So, the death of the integration environment. I'll move over for that. So the future is scary. No more integration for a start. The future is scary, right? I talked a bit about having to keep up with the newcomers in your market. Doesn't matter how big you are. These days, you have to keep up, Right? And if you're going to do that, you have to adopt new ways of working. And if you're going to adopt those new ways of working, you can't adopt parts of them. You can't say, right, well, we'll set the quote, we'll send all our project managers to Scrum training and then we'll be agile, right? It takes an organizational change to become agile. And it takes organizational change and adoption of lots of new patterns and practices to implement microservices styles of architecture. So finance isn't immune from this change. But, we have to learn this new stuff. How to build systems that are never done. How to deploy these things independently. How to test microservices in isolation and in production. But at the same time, the future's bright. This is a random thing, I like this slide. But by 2045, for $1,000, you can buy enough compute for the sum total of human brain capacity at the time on the planet, for $1,000. The future's bright. And also, all the stuff we've been doing, right, we can continue to do. It's turtles all the way down. All the OO kind of principles, practices that we've accepted and we've been using for years still apply. So these things like SRP, grass patterns, YAGNI, KISS, TDD and dry. But also, it's fun because we get to learn to do new stuff, right? We get to learn to write consumer-driven contracts, use semantic versioning, monitoring, test in production, and get really good at isolating failures. And that's me. Thank you very much.